So today we're going to be making a Google Assistant powered by the Raspberry Pi. Now this is inspired by the Google AIY project, which is artificial intelligence yourself, I think. But you can find out more about that project. I'll put a link in the description. They have a kit. It's called the Google AIY Voice Kit. Now, if you buy that kit, it comes with the voice hat, which is sort of a board that sticks on the top of the Raspberry Pi. I haven't bought the kit, but I thought we'd go ahead and make one anyway. And we're going to use the image that they supply for their kit and modify a few settings so that we can use one of these, which is a USB sound card. Lots of these types of things available. There's this one here, but I've chosen to use this because I like the cable on it. It means I can move it away from the Raspberry Pi. So these are all the kind of things that you're going to need. There are lots of different ways to set this up. So you could use the 3.5mm jack on the Raspberry Pi as your output device, but I'm just going to use both on here. So you'll need a USB sound card. You'll need, well, you won't necessarily need this, but it's a Wi-Fi dongle. So I can connect to Wi-Fi. Initially, I'm going to use the Ethernet jack. You'll also need an SD card. I've chosen a 16 gig one, but you can go down to 8 gig. I wouldn't recommend any lower than that. I've also got a 3.5mm jack, two 3.5mm jack, and one of these little lavalier microphones. This one was only a few pounds, so I'll put links in the description for all of these things if you want to pick them up. They will be affiliate links, so I'll get a kickback if you buy from them. I've got a breadboard with 2 buttons on and some DuPont cables, which are going to go onto the header on the Raspberry Pi. One of these is going to be for speaking, and one is going to be for shutting down and restarting the Pi. The other thing you may or may not need, you can use headphones if you want to, but I'm using an externally powered speaker so that you guys can hear it as well. So you might want to get one of those, or plug it into something else that's going to kick out some sound for you. Okay, I'm going to give you a little demo of this in action. So this is sort of fast forwarding to the end bit, but I'll let you see what it is, and then we'll come back and I'll have put these things together and we'll get programming. So this is our basic setup. We've got 2 buttons, one for speaking and also one for shutting down and restarting the Pi. It's currently running. You can see this is flashing. It tells us that it's working. So I can say, okay, Google, what time is it?
The time is 5:20.
Or I can press the button and just speak. What's the date?
It is Saturday, the 9th of June 2018.
Now let's shut down. You'll see that the activity light on the Pi is flashing, and then when this all shuts down, you'll hear it. There we go, so the speaker's now disconnected. This light will flash and then go off, and we can restart. So this is going to go through the boot process again. When it's ready, we'll see this start to flash, and then we can speak to it. It's a fairly nice little shutdown routine. Details are in the description of the article. So now that it's finished booting up, we can speak to it. So let's press the button. What is the circumference of the Earth?
Earth has a circumference of 40,075 kilometers.
Okay, Google. What is the circumference of the Moon?
Moon has a circumference of 10,921 kilometers. So
before I finish setting this up, all I've done is plugged everything in. It's basically adult Lego, but I thought I'd mention the 2 buttons. So one of the button is the speaking button. So it starts the conversation with the Google Assistant, and one is a shutdown button. Now they both connect to ground, so they have this common ground here. And so that's going to go on the top row there. I'll put a graphic on the screen so that you can see where each individual one goes. So each button is shorted to ground. They have internal pull-ups on those pins. So for the speak button, we're going to be connecting to the 8th pin along at the top, and that is GPIO 23. This also has a ground connection. So we can just choose one of the grounds. 3rd pin along from the top is ground, so we can use that one. And then the next one to connect is the shutdown button, and that needs to go to GPIO 3, which is the 3rd pin on the bottom row. So that's all of them connected. There will have been graphics on the screen so you can see which pins I was attacking at that point. So I'm going to be connecting through to this Pi using SSH, and I'm going to use PuTTY. Should be on the screen just there. And I've got the Ethernet cable plugged in. I'm going to be eventually changing over to Wi-Fi, but we need to set up those credentials first. You can use a COM port if you want and run through a serial to USB cable through the RX and TX lines. But for me, this is the approach that I'm choosing. So I've got an IP address of 192.168.1.107. And if I just press enter, it's going to disappear off your screen, but it'll appear on mine. There we go. So we've got a terminal on the screen. Now the default username and password is Pi and Raspberry. Now I've obviously already burnt the image that came with the Google AIY kit onto this SD card. I'll pop a link in the description where you can find all of these instructions to download it. But unfortunately, we have to do something very boring to start with, and that is update the package. And the reason we need to do that is because the Raspberry Pi doesn't always have the correct drivers to interface with these sort of plug and play sound cards. So we're going to update this one. This one's a C Media sound card. I think it's got the CM108 sort of chipset in, but we're going to be updating. So we'll do that over the Ethernet. If you were going to do this over Wi-Fi and you need to set that up, then you'll need to go to Raspberry config to change that. But we're going to just do that here. So sudo apt-get update. Now this is going to pull in the latest stuff for this distribution. So we'll just let it run through that. After that, we're going to be performing a command called sudo apt-get upgrade, and that's going to update any of the modules that are out of date. That's going to take some time, so we're going to skip through that. By time, I mean more than 20 minutes in most cases. I've got a fairly fast SD card in there. I think it's at least a class 10. And so it's going to be pretty slow. So updating the sort of list of packages is fairly quick, but this command is going to take a while. So I will come back when it's done. Right, so it's finished. That was a good half an hour, maybe 40 minutes. It took a while. After you've upgraded, you'll need to reboot. So I've just done sudo reboot, and now we're going to reconnect. So we'll restart our session. And we'll log back in. Okay, next we want to go to sudo raspi-config. This is the Raspberry Pi software configuration tool, and this is where we're going to change a few of the options. So first off, we're going to look at our boot options, and we're going to tell it to wait for the network when it boots. I'm just going to say yes. So it won't boot without the network, basically. And since this is an internet connected device, that's fine. Next up, let's configure our Wi-Fi. So if we jump into Wi-Fi, did I just go on the wrong option? Oh, I see. Let's just cancel that. And we'll put in our SSID. With PuTTY, you can paste in with a right click. So if you copy and paste from somewhere else, you can just paste in. So I'll just copy my SSID, paste it in, press enter, and then I've got to put my password in. There we go. So our Wi-Fi is now configured. And we're done here, really. There's a couple of things we could do. We can change our boot options so that we auto log into the console if we want to. We don't need to do that though. So we're going to cancel that. It is something I generally do, but it's not really necessary. So we're going to finish. It's going to ask us to reboot, which means we're going to get kicked out again from the terminal. I'm not sure what the fail here means. We'll go back in and take another look. I think it's because I messed around with the country, but I'm not too worried about it. There we are, we're back in. It's just a matter of changing my IP address. So Pi, Raspberry, and we're back in. Okay, so what's next? Well, we've got to change some of our audio settings. You can see that we've got our sound card over here. Let's just move some things over, shall we? and you can see it's got a red light on there. Now at the moment I can just see what cards are connected. And so cat proc a sound cards shows me that device number 1 is a USB audio, USB PMP sound device, C Media Electronics. We can also look at a play dash L for the list. Oops, a play dash L. I typed 1 there, and it gives us the same information, shows us what's available. So we can now change some of the defaults. So if we look at sudo nano etc a sound config, and so these are the defaults installed by this image. So this is the Google Voice Hat. We don't want any of this stuff. In fact, we could leave some of it, but we'll just take it all out for now. And I'm going to paste in our new code. So I'm just pressing the backspace key to delete all of this. There we go. And I'm going to copy and paste from the website that's linked in the description. And there we go. That's the information we want. So we're saying now that there is some question as to whether you need actually this options line. It's sort of a bit, depends on which version of the OS you have. But this says options sound USB audio index equals 1. So it's telling the OS to make it as 1. Currently it is actually set as 1. And then our PCM default is going to be a hardware interface, card 1. And then the CTL interface, the default one is hardware card 1. And that's what we want to do. So we're going to write that out. So Control O, confirm that you want to write it out. Yeah. Control X to exit. And now we need to edit another file. Now, again, this is because I don't know what system you're on. I think I'm fine to edit asound.config, and I don't really need to edit this one, but I'm going to sudo nano tilde /.a sound rc. Now it's got exactly the same information in here. And again, I'm going to just delete all of it. And then I'm going to paste in with a right click and put all of that code back in. So write that out and then exit. Now the last thing we want to do is tell ALSA, which is the audio interface software that Raspberry uses, which cards to use by default. Now it's got some settings of its own. So sudo nano /user /share /ALSA ALSA.conf. Now, we're not going to delete anything in here, but we are going to edit some stuff. So if you just scroll down this file quite a way, we'll get down to a bit that says defaults CTL card 0, defaults PCM card 0. Now, our default was 1, so we're going to put that in place of those. And that's it. We're going to write that out. So Control O rather, and then Control X to exit. Now, the next thing we're going to do is we're going to adjust the sound levels that ALSA is using, the gain on all of these cards. So we'll type ALSA mixer. This is a graphical interface for it. Now it starts off with pulse audio. This is like a little, pulse audio is like an exchange. It uses all of these devices and then it kicks out whatever format is needed. I don't really understand it, but that doesn't matter because we don't need to. So if you press F6, you get this little menu pop up. I love the sort of ASCII art on these things. We're going to drop down to USB PNP sound device, and you'll notice our speaker is set to 19. I'm going to pump that up with the arrow keys to about 80, 81. It actually jumps in 2 level increments. Then the mic, we're going to bring that up to around 50%. This one goes up in 2 increments as well. And then we're going to leave the automatic gain control on and just press escape to exit. And now we need to save those settings. So we do sudo ALSA CTL I assume it's ALSA control store. And then that's stored for the next time. Now we're going to reboot so that these settings take effect. And we should see this card flash when it reboots. Very briefly, it won't stay like that because there's nothing going to be interfacing with it. So once it reboots, it should detect that as the default. And then we're going to test that audio out. So again, we're running through Wi-Fi here. So if I just restart the session, I haven't seen that card flash, and it usually does. It doesn't necessarily mean anything. It might just be we've not used it before. I'm just going to wait for that network to connect. There we go. It is flashing. So it is being used. And restart the session on the terminal. Pi, Raspberry. And now we're in. Okay, so we're going to want to test this. So I've got a microphone over here. I'm going to bring this a bit closer to my face. We're going to need to turn this speaker on as well, actually. It might have run out of battery. Let me plug it in. Yeah, I think it had. Okay, so this is our speaker. Oops. It is on. You can see sort of a little white light on there. It's going to be sitting over there. Because it's plugged into power at the same time as playing, it's going to be a little bit noisy. But that's okay. I'll just turn it down, and when it comes to actually playing something back through it, I'll bring it over. So I'm going to bring this microphone a bit closer to my face. You're not hearing what I'm saying through this microphone. And we're going to try out a recording on here and see if it works with the inbuilt microphone. I think the first thing we can do is type speaker test. You can probably hear that very loud noise. So that is a test of the speakers. You'll also see that this is flashing, showing that it's working. So we'll just cancel that. Cancelling, hopefully. There we go. Sorry, it takes a little bit of time for that cancel to happen. So it is playing through, so that's great. This was flashing to show that it was being interfaced with. Now we want to try recording and then playing back that recording. So I've got a command here. You can copy and paste this from the website as well. It's a record. It's using the -D, which is the default. And it says 5 after that, which is a 5-second recording. So let's try it out. This is me speaking through a lapel mic plugged into my Raspberry Pi. Now let's see if that worked. Heaven knows. So you'll see at the end of that, I've put "they hear me recording, they hating" is the file name. So we need to play that. So we type a play and then just type "they" and it will fill in the rest. So let's see. This is me speaking through a lapel mic plugged into my Raspberry Pi. So we're going to do that again, a little bit closer to the microphone over here. I can hear it, but I know you won't be able to because this mic is very directional. This is me speaking through a lapel mic plugged into my Raspberry Pi. So I think what that tells me is we can probably bump up the microphone recording level and also probably the speaker level as well, actually. So let's just do that. So we'll jump into ALSA Mixer again and we'll press F6. We'll go to the USB sound card. Let's put the audio up to 91 and we'll take the microphone up to 80. Press escape and then we're going to store that again. Little tip, if you're going to be doing a few commands on the terminal, you can press up and down to repeat commands you've written before. So this sudo alsa ctl store is going to store our settings. So let's try recording one more time. This is me speaking through the microphone connected to the Raspberry Pi. Okay, so I forgot what I was going to say there, but let's try and play that now, shall we? This is me speaking through the microphone connected to the Raspberry Pi. We'll do that one more time because I forgot to bring the speaker over here. This is me speaking through the microphone connected to the Raspberry Pi. So that's actually fairly good. I'm fairly happy that's worked out first time. So turn that down because I don't like hearing the static. So now that that's fine, we just need to enable some of the Google stuff. Now this is a bit of a pain, but what you're going to need to do is go onto the Google Cloud, create a project. You need to have a Google account for this. Create a project and add the Google Assistant API to your project, and it will give you some credentials. You'll download those credentials as a JSON file, and that's what you're going to need now. So I can't really give you my credentials. It wouldn't be right. So I'm just going to go through the steps here, and if I need to blur anything out, I will. But mainly the details for creating the credentials for this can be found on the Google AIY website. So we need a way of pulling in the credentials to the Pi. So we're just going to create a file, sudo nano /home /pi /assistant .json. Now this is the file that it's going to be looking for. So it needs to be this, probably not that name actually. Let's try that again and spell it correctly. There we go. So it's going to be looking for this particular file. So I've got my JSON file open on my desktop. So I'm going to copy and paste all of that information into here. So just paste it across. You can't see all of the stuff that's in there because it's sort of scrolled over here. So that's fine. And then we're going to write that out. Control O, enter, Control X, exit. Now the Google Assistant library or SDK or whatever you want to call it, the kit has an automatic way of authenticating the user. So if we just jump into their project directory, so cd aiy-v, voice, I think it is. It'd also help if I spelled things correctly. So cd aiy voice kit Python, and then we're going to run one of the examples. So I'm going to copy and paste this so that I don't have to type it all out. So the example is source examples voice assistant _grpc demo. Now this one is all it's going to do is automatically request the credentials, and then we'll be able to speak into it. So it's asking me for this URL. I'm going to blur out one of these lines so that you can't see all of that. But we do need to copy and paste this. Now in PuTTY this is a little bit of a pain because when you press Control C to copy, it exits whatever program you're in. So if I just press that, it says that we've exited it. So but now I've copied it, I can go to that browser address. Now this address, all it does is it goes into your Google account and it will ask you to authenticate the application and it gives you a response. So if I jump back here, we're going to run that again. And again, I'm going to have to blur out a line unless I've taken it off or left it on rather. And then I'm going to paste in my response. Again, this is going to be blurred out that part of the screen. And then we press enter. And it's going to authenticate our credentials. And now I can actually talk. So we've got our button connected. So I'm going to speak to the microphone and press the button. What time is it?
The time is 7:07.
I'm going to do that again, but I'm going to bring the speaker over. In fact, I'll just turn the speaker up. What time is it?
It's 7:07.
I'm going to send the microphone a bit further over so you can hear what she's saying. What time is it?
7:07.
Hopefully you can hear that. What's the date?
It is Sunday, the 10th of June 2018.
So to me that's fairly loud, but to the microphone here it's not going to be too loud. But that's okay, so it's working. So what do we do next? Well, we need to create a service. So if I exit that now, Control C will exit. We need to create a service so that this script runs when you boot the Raspberry Pi. But I don't want to use that particular script. I'd like to use a different one. They've got an example which is really great. So their example that I really like is called the Assistant Library with Button, I believe, demo. There we go. So so source examples voice assistant with library button demo. So if I just press enter, this one will actually interact with us not only from a button but also from speaking. So we'll just let it run out. There we go. So we've got the ability to say OK and then the G word, or press the button. So if I say, I'll bring the speaker over again. OK Google, what is the temperature?
The current temperature in Leicester is 21 degrees Celsius.
You probably didn't hear that. I turned the sound down again. OK Google, what is the temperature?
In Leicester, it's currently 21 degrees Celsius.
Let me unplug the power from this. That'll make it sound a lot nicer. OK Google, what is the circumference of the Earth?
Earth has a circumference of 40,075 kilometers.
OK Google, tell me a joke.
Why are chemists bad at playing pranks? They lack the element of surprise.
Well, there we go. So it works. And I like this example because not only can I use the button to say, what time is it?
It's 7:10.
And you don't need to say, OK Google. Oh no, it's just going to recognize that, isn't it?
Hi, what can I do for you?
Brilliant. But I just prefer being able to press the button and speaking. And it's going to work really well with a project I've got coming up with an old telephone. So this old telephone is going to become... Google's still listening to me. It's going to become the device in which you speak to the assistant. And I want it to not listen when I've put the handset down, so that I only want it to speak on a button press. So that should be fun. Anyway, we need to be able to make this work on boot so that we don't have to run it each time and log into a terminal. You just want to be able to turn the thing on and have it happen. So now that we've got our speakers working and our microphone working through the USB sound card, we need to create our code. So I'm just going to copy that example where you can just speak to it because it's very useful for this. So we want to, let me just copy the, sorry about that. I accidentally unplugged the Raspberry Pi. So we've had to start again, unfortunately. Hopefully nothing has changed. So what we'll do is we'll run that example one more time just to make sure it's still working. And then we'll continue adding the service. So we want to run the service so that it begins at boot. So we're going to choose the same file that we just looked at, which was the example with the button. We'll just make sure that still works. And then we'll jump into creating a service. So I'll just paste in that file. Hopefully we should see this start to flash and it will come up with some instructions on the screen for us. Yeah, okay, so I can say, OK Google, what's the date?
It is Sunday, the 10th of June 2018.
Yeah, so it's still working, so we're okay. So nothing bad happened there, so that's good. Right, so let's create a service. Now, I think the first thing we should do is copy that file that we want to use into a new place. So we're going to say copy, and then we'll paste in the file name. We're going to copy it to source/main.py. And so now if I type cd/src and list, we've got our main py in there. So cd, let's just jump back. And we need to create a service file now. Now a service starts on boot with the Raspberry Pi and it remains running in the background. It'll also restart if it stops for some reason. So we need to say sudo nano, let's call it pi assistant dot service. Now I've got some text on my website that you'll need to copy and paste to put in. So I'm just going to copy that now. And then we're going to paste it in here. Now this describes the service. It tells it what environment to run in. And it says what it's going to start, which is source/main.py. The working directory, which is the AIY projects Python directory. And also it's the restart and user pi. So let's write this out and we'll exit. Now we need to move that assistant file. So we'll say sudo move pi dash assistant, and we're going to move it to /lib systemmd/system. Enter. Now we need to enable that service. So to do that, we just say sudo systemctl enable pi dash. It should fill in the rest for us. And that's been enabled. And we can actually start that service now. I think there's something we're going to have to do with some permissions in a second, but let's leave the service for now. Actually, can we just start it as pi? Let's see. Yeah, it looks, oh no, we don't have permission as pi. So let's not do that. We need to change a couple of permissions first. So we've got Pulse Audio installed, and if you recall from the text that we just pasted in, it's going to try and create something in the environment, so the run user 1000 directory. So we just need to make sure that it has access to its areas, the config areas. So let's just make sure that we own the directory. So when we come to run this, we'll be able to use it. So I've put these details on the website, but it's we're going to say that we own that. I've just pasted in something extra. So we'll say we own that folder. And we're going to give certain read-write permissions to it as well. So chmod 755 to the config file. And now we're going to start the service. So let's just do that as sudo. We may have to come back and change those permissions again on those folders. I'm not sure. It has worked. So you can see that this is flashing. I can say, okay, Google, tell me what the date is.
It is Sunday, the 10th of June, 2018.
Okay, it's not very loud. Let's go to Alsa Mixer again. And see what's going on here. So F6. No, it does appear to be loud. I think the speaker's running out of power, so it could easily be that. Let's just jump out of there, and then we're going to reboot. And if we've done everything correctly and in the right order, this should start on boot. So sudo reboot. That little bing means that my computer has now disconnected from the Pi, and we'll see if this works. I'll speed through this, so hopefully it'll start now. And yes, after a reboot, the service is running again, so we can just say, okay, Google, what is the date?
It is Sunday, the 10th of June, 2018.
Took your time there, but she did answer. So it is working. We've got that working. Now what we want to do is create the shutdown button so that we can turn it off at the touch of a button and restart it. So let's clear this screen. And log back in. Right, now we need to create a file which is going to run our shutdown script connected to GPIO 3 on the board. Now we're going to jump into a directory, so cd/home/pi. We're already in it, that's good. And then we're going to create something, so sudo nano, and we'll call it shutdown _pi.py. Now I haven't written this, I've actually got it from a GitHub address. So that address and the details of it, who owns it, which is Halo FX on GitHub. There's a link on the webpage, you can download this. So I'm just going to paste it in. So this is, this is the code for it. I'm going to have to take out these extra spaces because it will not like that. So just going to delete those. Let's just change those to tabs instead. When you're copying and pasting text, tabs and things like that tend to go a little bit out of whack. So that's our file. So we're going to write that out. Oh, actually, before we do that, so we'll cancel. You can see here that we've got GPIO3 set and it's got a pull up on it. And so that means when we ground that button, it's going to call OS sudo shutdown -h. -h means halt, I believe, and now. So it does it straight away and it will shut down. But when you short pin 3, GPIO3 to ground, when the Pi is shut down, it will reboot. So it's a really excellent little script. I'm very impressed with it. So let's write that out and then exit. And now we need to edit files. So this runs on boot. And we'll have to do this again. So reboot again. So if we edit sudo nano /etc rc.local, this runs on boot. So just after that if statement, we need to pop our code. So what we're going to say is sudo python /home /pi /shutdown _pi pi.py, and then we need an ampersand, so it's non-blocking, I think, and that's it. So we'll write that out, exit, sudo reboot. We've already got a button connected up here. That's the one with the blue wire. So hopefully when this reboots, we'll be able to shut down the Pi with a press of the button. In fact, we'll see if we can get the Google Assistant talking, and then I'll shut down mid-sentence so that you can hear it. And then I'll press it again and show you that it will reboot. So when this has a constant flashing, we'll know that the Pi has rebooted. I no longer need to be in the terminal. So it looks like we've now rebooted and our service is running. And now we can test out the shutdown and restart button. So let's ask Google something without pressing the button. Okay, Google, tell me about the flat Earth.
According to Wikipedia, modern flat Earth societies
I think that's enough of that. So I've pressed our shutdown button and it should switch off the Pi. So we'll probably hear it click, but we'll also see the light go off here. And I believe the light up there will flash about 4 times after that's happened and then go off completely. And then I can press the button again now to restart it. It's hard to see what the light's doing there, I guess. So you can see the lights come on again here. So we're just going to be waiting for it to start flashing again and getting into that fully rebooted services running mode. Okay, well, it looks like we're back in the services mode. So I could say something like, okay, Google, tell me how big our galaxy is.
Here's a summary from the website bbc.com. We are fairly confident that the Milky Way is probably between 100,000 and 150,000 light years across.
That's pretty
The
big.
observable universe is, of course, much larger.
Of
According
course.
to current thinking, it is about 93 billion light years in diameter.
Well, there we go. So that's it. It is fully working. We've got our shutdown and restart button. We've got our speak to Google button, which still works. So we can say, oh, I don't know what to say. What is the circumference of the sun?
Sun has a circumference of 4.379 million kilometers.
That's a lot. So we can ask it questions. Now I'm going to be transferring it over to my rotary phone, so that I'll be able to hear it through the speaker and speak through the speak microphone. And I'm going to make it so that it cannot listen when the phone is down on the hook. So it should be fun. Anyway, head over to the website. You can pick up all the instructions there and some troubleshooting tips. It also has some nice images of all the pins and stuff and what you should see in the terminal. All right. Well, I hope you've enjoyed. It's probably been quite long, but I haven't done a tutorial in a while, so I'm a little out of practice.